Hi everyone, I'm Yamini Rao. I'm a developer advocate for IBM. I just want to check if my sound is okay. Okay, sound is all good. Um, Let me just, yeah, right. So, hi everyone. I'm Yamini Rao. As mentioned, I'm a developer advocate at IBM. In this session, we are going to be doing some data science 101 with Python and Pandas. I'm going to start off with a quick introduction and then we'll move on to working on Watson Studio on IBM Cloud to run through a Jupyter notebook and work through some of the basic Pandas commands, and you can use that as reference to work with your own data set. So let me just share my screen. Right. So for those of you who are new to Pandas, Pandas is an open source Python library which allows for high performance data manipulation and analysis, using its powerful data structures. And it's one of the few things that's good to know if you want to get started with data science. And with the combination of Python and Pandas, we can accomplish, the 5 typical steps in the processing and analysis of data, regardless of the origin of the data, like loading, preparing, manipulating, modeling, and analyzing your data. And Pandas deals with two main data structures called your series and your data frame. Let's look at this in a little more detail now. So series is a one-dimensional labeled array, which is capable of holding data of any type, your integer, string, float, etc. And it has an associated label with each element or an index. And this could be, this is very similar to a list. And your second data structure is a data frame, which is two-dimensional, where data is aligned in a tabular fashion in rows and columns. So here, you could have different, potentially different columns with different data types. And here as well, you have labeled axes, your rows and columns are labeled, and you can also perform arithmetic operations on these rows and columns. Now, this you can think of as an SQL table or a spreadsheet data representation. And so Pandas deals with these two main data structures for data manipulation, series and data frame. And there is an extension. So if you do have, geospatial data and working with some geospatial data, you can use GeoPandas, which again is it's sort of an extension of Pandas, which allows to which allows to work with geospatial data a lot easier in Python. And again, it extends the data types used by Pandas to allow for spatial operations, and you have GeoSeries and GeoData Frame, which are again subclasses of your Pandas series and data frame, respectively. So in this session, we're not going to be covering GeoPandas, but if you are interested and if you do want to work with, if you have geospatial data you're working with, you can let me know, and I'll share another notebook which you can also refer and work with if you are working with geospatial data and would like to use GeoPandas. And again, you can perform geometric operations on all of the data, and this is performed by Shapely, which is another Python package for manipulation and analysis. So we've just covered a brief about GeoPandas, but in this session we are focusing more on pandas. And this is just representation to show you, how pandas works. In with comparison to GeoPandas. In pandas, you have your series and data frame where uh, data is in rows and columns or as a list or in a one-dimensional array. Or you have GeoPandas, where you have your points and then your lines and then your polygons. All of this to work with geospatial data or perform spatial operations. And this is a notebook. It's useful if you're getting started with data science. It's a handy book you have to take a look at. So you can take a look at this for if you are getting started with data science. It has a lot of useful stuff about Python and pandas and how you can use them to work with data manipulation. And this is just reference. And right, so today we are going to be working with Jupyter Notebooks, which is an open source web application which allows us to create and share code and documents. So what you can do is, so Jupyter Notebook basically provides an environment where you can document your code, run it, look at the outcome, visualize your data, and see the results without having to leave the environment. So this makes it a very handy tool for performing end-to-end data science workflows. And you can install Jupyter Notebooks, using the Anaconda distribution. So once you use Anaconda, it installs both Python and Jupyter Notebooks for you together. Or you can also use any cloud platform to host your Jupyter Notebook. And today I'm going to be using IBM Cloud and Watson Studio to run our Jupyter Notebook. Right, so that's a quick introduction about pandas and its data structures. We can move on to working with the Jupyter Notebook now. So this is the link to the workshop, which has all of the information, the Jupyter Notebook, along with all of the different steps to set up Watson Studio and how you can host your notebook on Watson Studio. I'm going to cover all of these steps in this session today, but you can always refer back to this GitHub repository if you've missed something. And I'm just gonna switch quickly to Watson Studio. And I also have an eye on the Twitch chat. So if you have any questions, please leave them in the chat and we'll address them. And if you do want me to repeat something or go through something again, or go through another step again, so please let me know and I can repeat that for you. So I'm just gonna also put this in the chat. Sorry about that. That's not the link. Let me just. Right, that is the link. And you can also use refer the first link if it's a quick introduction to Pandas. It's a 10-minute tutorial to Pandas, which is part of the pandas.pydata.org website, which I've also linked through within the Jupyter Notebook. But again, that's a link you can use for a quick introduction to Pandas as well. And the second link I posted is the link to the GitHub repository, which you're looking at right now, which has all of the information, all of the different steps to sign up to Watson Studio and also the notebook as well. So this is a URL for the notebook, which I'm just going to show you in a minute how you can set it up within Watson Studio. But you can, sorry about the scrolling, you can, access a notebook just from here, which it's called Working with Structured Data and Pandas. So so you can use this as well to download the notebook to your system, or you can access it directly using the URL as well. So I'm going to quickly switch to my IBM Cloud Dashboard. Right, so if once you've signed up to IBM Cloud, this is what you should see, your dashboard. And the first thing we'd want to do is look for Watson Studio. And I'm going to bring that up. You can also use this option on your top right to create resource, or you can use the top nav to search for a service that you'd want to create. Right. So once this loads, you can choose a location here, which is the location closest to you, and leave the defaults. You can give your service a name, etc., and click create. And once that's done, and once you successfully create your service and click through, sorry, just waiting for that to load. Right. So once this, you can choose a location and click create, and this should bring up your Watson Studio service. I'm just going to open up mine. Sorry, that's taking some time, but it should come up any minute now. Right. So once you've created your service, this is what you will see, an option to get started. And go ahead and click through to get started. And this should bring up the IBM Cloud Back the Data platform, which is your Watson Studio dashboard. Right, so once you're within the Watson Studio dashboard, what you can do is you can create a project. So projects are nothing but a folder structure for everything that you work on within Watson Studio. So you can either, if you have an existing project, you can use that, or you can create a new project by navigating to this option right here. Just navigate to projects, and you can create a new project. So these are all my existing projects. So you can just use this option on your top right to create a new project. And you do have an option to create an empty project, or you can work with an existing sample or file that's within Watson Studio, or if you have a data set of your own, you can use create an empty project and then work with your own data to sort of analyze or model your data. So I'm going to create an empty project and give my project a name. Right. So in this section, you have your Cloud Object Store. So if you're doing this for the first time, you wouldn't see this. You wouldn't see this populated. You would need to create a new Cloud Object Storage. So if you look in the GitHub repository, I've sort of put in the steps here. So if this is your first time creating a project within Watson Studio, this is what you will see: an option to create and add a Cloud Object Store where all of your assets will be stored within this project. So you can do this and come back to this page and click refresh, and that should populate your the object store that you've created. And yeah, so once that's done, you can create your project. Okay, so this is the project dashboard, and here you can see you have a number of options. As mentioned, all of the different assets you work within this project will be in this tab. You have your different environments that are available for you, your jobs, and access control. If you are working in a group, you can provide access to this project, to your group members by using this option right here, and other settings about the project itself. Oops, sorry. Right, so once this loads up, the first step you would need to do is to add something to your project. So when you use this option on your top right and say add to project, you have a number of options here, and you can choose the appropriate asset type that you'd want to work with. Today, we are going to be using this option here, the notebook option, to upload our Jupyter notebook. But you do have a number of options you can use here to work with your data. So you can upload a data set of your own and work with creating a visual recognition model, or you can work with NLP, NumPy, or you can also create deep learning models. And another useful thing that you can do is create your own machine learning models, like AutoML, using Auto AI, the Auto AI experiment. And what this does is, it takes your existing data and creates model pipelines for your existing problem at hand. So if you do want to create a classification or a regression model with an existing data set, you can run it through Auto AI to create different pipelines. And then you can deploy those pipelines as a machine learning model and use that model externally. Using the API endpoints, and if you want to use it externally in another application, you can do so by using the API endpoints, or you can deploy the model and test it within Watson Studio as well. So this is another handy tool for automated machine learning. So if you do want to create models, you can use this. And as mentioned, you have a lot of options here to work with your data. You can also use a Cognos dashboard to visualize your data as well within Watson Studio. So for now, we are going to be using the notebook option to upload our notebook. Now, once you've done that, you have three options. You can upload the notebook from locally from your system, from a file, or you can create a blank notebook and start working on it from scratch. Or you can also upload a notebook from a URL, which is what we are going to be doing. So I'm going to click from URL, and we're going to take this. We're going to put that there, and you can leave the default runtime as Python 3.7. But of course, you have a whole lot of other environments you can work with depending on what it is that you are working on. So I'm going to leave the default Python runtime and add my notebook URL, and also give this a name, and click create. Right, so this should bring up our Jupyter notebook, and then we can start working through it. So as previously mentioned, you can use this GitHub repo to work through all of the different steps we've just gone through, and it's all documented with screenshots of if you've missed something, or if you do want me to repeat a specific section from this workshop, please let me know. I can repeat that for you. But yeah, starting from a link to sign up to the IBM Cloud account, and how you can set up your Watson Studio service and your Jupyter Notebook are all documented within this GitHub repository. And yeah, if some of you are interested in working on GeoPandas, please let me know. I'll leave a link for another notebook which has some. I think we're using some UK crime data to work with geospatial data, and also some data about all of the different boroughs in London, and it uses pandas and geopandas. And if that's something you'd want to work on, let me know, and I'll leave a link to it there in the chat as well. And for now, right, so our notebook is waiting for our notebook to load. That should complete loading. Right. So the notebook's now completed loading. So this is what you should see once your notebook is successfully loaded, working with structured data and in Python using pandas. And these are all the contents of our notebook. So what we're going to be doing today is just data manipulation, and then visualizing our data using two different Python packages, Mapplotlib and Cbond. And a little bit about the data we're using today. So this data is what we are using to explore within this notebook, has some data about all of the different boroughs in London, and the data has been acquired from data.gov.uk. So this is the link to where you can find the original data set. So you can navigate to this link and get the most recent data set as well. But we are using a URL to sort of extract the data. So it's always picking up the most recent version, but you can have a look at the existing, if you need some more information about the data set itself, you can find that in this link. And right, so what we're doing is we are using this data set with some information about the London boroughs, and we are using some Python commands to clean the data and clean, group, and then visualize the data. Be data manipulation basically, and then moving on to visualizing it. So starting off with the first cell. So if you're new to Jupyter Notebooks, it works in a very sequential manner. So it's made up of different cells with code and markdown. So please make sure to read everything that's in between these cells, because it has some useful information and links about everything we're talking about. The code or the Python commands that we reference within each of these cells. All of the links to it are sort of mentioned within the markdown section in between these cells. So make sure to read all of this. And yeah, so you have your markdown with some information about what's in each of these cells and the actual code as well within the cells. So one way to run it is to use this option in your top nav to run each cell. You can use these options to add a cell, delete a cell, copy, paste, etc. And a shortcut to run the cell is Shift Enter. If you want to do it, if you want to use your keyboard for it, is Shift Enter, or you can use this option as well. You highlight the cell and use the Run option. If so here you see these open brackets. If a cell is not run, that's going to be empty. While it's running, you will see a star, and once it's completed running, you will see a number. So I've just run the cell, so it's completed, and it says 1, and you will see every cell be get populated with a number, so you will understand the sequence of how you run the cells. It's advisable to run them in sequentially, because sometimes the earlier cells later on dependent on the cells that you run previously in the notebook. So right, so the first cell we have here are the packages. We're importing Pandas, of course, and Numpy. Numpy is again a Python package which is used for working with data and arithmetic operations, to perform different arithmetic operations on your data. Numpy is a great package within Python, and we're just importing them as NP and PD. This is just for ease of use, to not have to type Numpy and Pandas every single time. And right, so that's done. And the second step, we are uploading the notebook itself. So we're reading from, as I mentioned, we're reading the data directly from data.gov.uk. So it's always the most recent version of the data. What you can do is you can also host this you can use a different URL, depending on where your data set is hosted, or upload it using the Cloud Object Store. You can even store the file in the Cloud Object Store that you've just created and upload your file from there as well, or import it rather. And yeah, so moving on, I'm just going to sort of work through all of these cells. Most of them are, have a lot of information between each of them, so you'll understand what's happening. Yeah, in the interest of time, I'm just going to breeze through. You can use this as a reference to upload your own data set and work with the Pandas data structures. So yeah, so let's look at the first step. So what we're doing is we are dropping some of the columns. So if you've seen the original data set, the last 4 rows have some null values, don't have any values, other they're just empty rows. So we just want to get rid of these, as they're not useful for our data processing. So what we're doing as a first step is just dropping the last 4 columns. And so yeah, so when you're doing a data manipulation and you want to see the output of your data, you can use df.head, which brings up the top five rows in your data set, just to understand what your output is. Or you can also provide a number, as I've done, within the brackets to display the number of rows using the head command. And this is now our data set. As you can see, you have your area code, area name, if it's part of inner or outer London, the population estimate, etc., etc. A lot of these, your average age, and the proportion of population, age 0 to 15. And so, yeah, it's just some supporting information about all of the different boroughs within London. Right, so there are a few exercises that you will see within the notebook, so for you to try out these commands yourself. So as mentioned, you have df head, and df is nothing but the data frame that we're creating. Sorry, I should have mentioned that. So as a first step, we're just using df as a variable to create our data frame, or a data frame to store our data set within. That's what we're doing to easily identify our data set. So df is what we're naming it. And yeah, so you can use head or tail. Tail again works like head, but you just to display the bottom 5 rows. It works very similarly to what head does. You can also provide a number within the brackets as well to bring up as many rows as you want. And you have other, other commands like dtypes, which is your data types. If you want to identify what data types each column belongs to, you can use the dtypes option, or you can use columns. Columns to give you a list of all the columns, and len to give you the number of rows, and shape, which gives you the shape of the data set, basically your rows and your columns. And yeah, so here you can, as mentioned, you can try each of these. You can add as many cells as you want within the notebook and try these for yourself. And yeah, and add as many cells as you want and try these different combinations using these commands. And moving on to series and data frames. So this is what we've previously seen during during my introduction. You have a series, which is your one-dimensional array, and data frame, which is two-dimensional, which is your rows and columns. And here, what we're doing is just creating a basic, a basic data frame with using our series command. And all I'm doing is using these values to put them in data frame. And as you can see, it automatically, provides an index and gives you a list that's generated while using the series command. And moving on to the next bit, which is your data frame. So we're going to build our data frame using some of these different options. And there is a link here to Numpy as well. So as mentioned, Numpy is used to work with multi-dimensional arrays or matrices and work with all of the different arithmetic or mathematical functions that you'd want to use to operate on your data is all part of Numpy. So this is a useful link, to get to, to sort of look at. Let me just show you. It's just numpy.org, and it brings up all of the different commands and the different parameters for these commands, which you can use within Numpy itself. So yeah, so have a look at that link. And as the next cell, we are using date range. So what we're using is we're just using a date range for 6 periods and bringing this up, which is starting from 1 to 6. And again, all of these are part of the Pandas package, right? So each of these commands are all inbuilt, and they're available for you to use. If you want to generate a random set of numbers, you can use the RANDN function and generate a set of random numbers as well in 6x4 matrix. So all of these are inbuilt and available for you to use within Pandas. So here what we've done is we've created a date range, and we've created a set of random numbers in a 6x4 matrix, and we're putting all of this together in a data frame. And we are using our dates as the index and also naming our columns. So this way you can just create a data frame, which is which is pretty straightforward, with the different numbers you've generated and using your dates as the index here. If you do not specify dates as your index, it's going to give you just your array, your 0, 1, 2, 3 as the index values, but you can also choose to assign any other columns as the index. Right, so these are just other examples of creating a data frame. I'm just going to execute each of these. So yeah, I'm just going to touch base on each of these cells quickly in the interest of time. You can always work through this notebook. It's pre-populated, and you can reach out to me if you have any questions about the notebook as well. But today I'm just going to breeze through and touch base upon just briefly on each of these cells and what you can do with these different Pandas commands. So right, so here is another example where what we're doing here is putting everything together in one command using a timestamp, series, array, and some categories of values, and putting all of this together in a data frame. Here, as I mentioned, if you do not provide an index, you have an index that's automatically assigned to your data frame. Again, this can be used to work with large data sets, and this is merely an example of how you can use the pandas commands to work with data. But you can definitely use this and sort of add on and do a lot more with these existing commands. And moving on to cleaning our data. So what we're doing here is creating a copy, so we don't change our original file. So we're creating a copy of our data frame that we created, and you can use new to add a new column. So if you want to add a new column, you can use the new option. And here we've assigned it a value of 1. So the last column, as you can see, will be new with all, with values 1. And you can also use drop, as we've previously done in our first step, to drop or delete columns if you want to eliminate some of the columns from your data set. Drop is a useful function. And here, what we're doing is we're dropping all of these columns as, because we're removing all of these, as this would not be useful for, since we're not interested, or it's not going to be useful in our outcome or final processing of our data. We are dropping all of these columns. Again, feel free to remove some of these or keep some of these as you wish. So this is just something that I've added because none of these columns are seem to be useful. So we wanted to sort of keep it, keep a few columns for our data manipulation, but you can choose to keep all of these or delete or remove as you wish within this cell. And now, as you can see, I've just executed this command, which is columns, which brings up all of the different columns within your data set. And this has all of our existing columns after we've eliminated all the columns previously. And you have your area code, area name, etc., and all of the basic information about the different boroughs. And and you have a rename as well, using which you can easily rename your columns. Some of these are just not very readable, so we're just changing these names to give it a more readable name. So yeah, just changing it to inner outer London and population, etc. So you can use just one big piece of one just one cell, and give all of your area names or all of your columns, and rename these columns. You can do it one at a time, or you can also just group them together as well within the same cell. And now I'm going to execute this bit, and so now, as you can see, it's a lot more cleaner and easier for us to read and identify each of these columns. And I'm going to execute this now. So now we've got our columns that have been renamed, different columns that have been eliminated that we don't want to see, and it's also and been given a different name for each of these columns. Now moving on to further data cleaning. So you can use describe. So describe is a function if you want to get a quick overview of the numeric data. So if you have different numeric columns, you can always use describe to sort of accumulate all of these to check if they all look fine. So previously, as we've seen, some of the values within, I think, turnout at local elections and a few other columns had had null values or had just a dot. So we're just replacing these with an NaN value for ease of use, and for our visualizations to work better. Sometimes the null values, things don't seem to work the way you'd want them. So it's always good to replace any missing values with an NaN. And I'm going to just bring up the data types to show our different data types of the different columns. So here you have all of the different data types for our different columns within the data set. And so except for inner and outer London, largest migrant population, and political control, everything else needs to be numeric. So what we can do is use this option, which is just PD to numeric, and change the data type for our different columns. And now what we've done is, we've just made them, we've just changed it to float and integer to change them to numeric. And here, as you can see, a lot of them were strings. So yeah, except these three: inner outer London, largest migrant population, and political control. Everything else should be numeric columns. So this way you can easily change this up to change your data type to numeric. And moving on to the next section, which is selecting your data. Ooh, sorry about that. There is an error. It's my kernel. Let me just restart my kernel. Give me a minute. So yeah, if you've run into any issues, you can restart your kernel. I lost my cell. Just bringing it up. Yeah, so selecting data is where we were. So this is the section. So yeah, so about selecting data, so you can use the .loc function to select your data. So what we're doing here is, oops, okay, let me just, I think change something. Okay, right. Sorry about that. I think we've not run or we've changed something previously. So there is an error with E901. Okay, let's use iloc then. So if you want to choose or access a specific row or column within your data set, you can use LOC or iloc to actually and provide a number within the brackets to sort of access each row or each column. So here what we're doing is we're using iloc to access our first column here, which is our area code, and all of this is part of your first column. What you can do is also use, provide two values, and this works in an n-1 sort of way, where you can use this is the first row and the first column. So here, this is our index and our first column. And moving on to another example, this should give you a better example. So here what you can do is, like I said, you have your index and then columns from 0 to 2. So this works as n-1. So if you give this as 3, it's going to give you 0, 1, 2, the first three columns. So this way you can use iloc to to sort of access your different columns, different columns and rows. And so you can use, so what we're doing here is accessing columns 2 to 3. So here, as I mentioned, you have, this is going to give you n-1 column, and we provided the value 4 here. So it's going to give you 2 and 3, and 0 to 2 as well. So that's going to give you the first two columns, which is 0 and 1. And so this way you can select data or work with specific data sets, so subsets of data within your data set, or access each of these within the data set. And and moving on to filtering, we've got these. Let me just show you this, right? So the filtering bit is, again, very simple arithmetic operators. You can use greater than, less than, equal to, and just basic arithmetic operators, and this gives you like Boolean indexing. So what you can do is you can so this one, what we're doing here is checking which of the borrows have an average age of greater than 39, and this is going to give you return a Boolean value. But if you do want to return actual values, you can use this option here and use borrows, and then provide your actual command within another set of brackets. This is going to give you all of the actual values for the different data sets, where the borrows are whose average age is greater than 39 is going to come up. Or if you just want to bring up Boolean indexing, you can use just this bit here. That's going to just give you a true and false or Boolean values for your output. And again, very similarly, as I mentioned, you can use different arithmetic operators. What we're doing here is checking if where the average age is greater than 39 and the political control are conservatives, and then you have equal to, or, so you can use all of these different arithmetic operators to to work with your data. And right, so there's another bit of exercises here. So please do try out, try these and try answering these questions. All of these are based on all of the code we've just seen. So the first question here is, which borough has the largest population density per hectare? So do give it a try. Add as many cells as you'd want and execute. Try the commands out yourself. If you do want the answer to these questions, you can find them here in this cell. So all you have to do is delete this hash sign, execute this cell once and execute it again. That's going to give you the answer to the exercise questions. And again, this is another answer here. And these are questions as well, which are provided here. So this is going to bring up the answers for the exercise questions, but yeah, do try them out yourself first before looking at these answers. But yeah, if you do get stuck, the answers are all there. And moving on to the last bit of our data manipulation, before we move on to visualization, you have merging your data. So in this bit, we're using different data sets. We're not using our original data set. We are just using different data frames that we've created with city, population, and area as the columns. These are our 5 cities with population and the area per hectare. And yeah, we've got 2 different data frames here called data and data2. And then we're using them, we're putting them into 2 different data frames called cities and cities2. And we can use different functions here now to merge our data. One of them is append. Using append, you can combine your 2 of your data frames. So here, as you can see, our first data frame had these 5 cities. The second one had Liverpool and Southampton. So what you can do is you can combine 2 data frames using append. Again, as mentioned, we'd be doing this with data frames that we've created, but this would definitely work much better. When you have really large data sets that you'd want to merge, you can use Pandas commands to easily manipulate and merge your data. And then we've got another data frame here, which we're adding with the density, I think. Yeah, and it's called cities3. And what we're doing here is using merge to do an outer join of the cities. So because you've got the city and population, which are common, city and city, which is common in both of these data frames, we're using the density column to sort of do an outer join to merge all of these different data frames. Right, and moving on to grouping your data. You can use group by, which is a very handy command if you'd want to group multiple subsets of data within your data set. So here, as you can see, what we're doing is we are grouping, inner and outer London. So this brings up this is a quite handy command to sort of calculate the mean or the median of your values, or all of your numeric values, and group it based on the different categories in your data set. So here what we're doing is we're calculating the mean, and this is going to bring up mean of all the numeric values you have based on 2 different categories, inner versus outer London. And again, another example is to create the sum of all of the different values, and this is going to bring, and here what you can do is you can also, when you have multiple categories, you can also use group by to sort of accumulate these different categories as well. So first what we did is just use inner versus outer London, and here what we're doing is we're also using political control. So you can use all of the different categories as well to group different subsets of data within your data set. Right, so this is all about the data manipulation. Hopefully this was useful, and if you have any questions, you can leave them in the chat or reach out to me later on as well. Moving on to the last bit, which is visualizing your data. Now, up until now, we've selected our data, filtered our data, grouped our data, and used all of these Pandas commands to manipulate our data. And now we can, move on to visualizing our data set. So what we're using first is Mapplotlib, which is for lack of a better word, the OG Python package for visualization. And Mapplotlib has a MATLAB-like API, which allows for basic visualizations, and you can sort of use other packages that are added on to Mapplotlib or based on Mapplotlib, like Cbond, which we're also going to be using for some more advanced visualizations, which have a more advanced API as well. So starting off, what we're doing is we are again importing the Mapplotlib package, and we are resetting our index as a first step. So let me just clear output. Sorry about that. I'm just going to restart my kernel and clear my output for our visualization. Right, so executing this as our first cell, which is our Mapplotlib package, as mentioned, and we are resetting our index. Oh, I'm just running all the previous cells, just waiting for, because we've created borrows and all of our different data frames previously in the notebook. So when you restart your kernel, you do have to run all of the previous cells as well for this subsequent cells to work. So so what I'm doing is, as mentioned, importing the package, and we're resetting our index. So if you remember, we did reset our index to our area code. So we're resetting it back now to sort of have just the arrays, your 0, 1, 2 values, for our visualizations to work better. And our default plot here is a line plot. And what we're doing here is we're plotting our employment rate and just using dot plot. And this is going to use the line plot, which is our default plot for visualization. And just doing that and moving on. So as mentioned, you can use some of these links to look at all of the different. Let me just bring this up. All of the different parameters and everything that you can use with each of these commands, right? So what we've done is just showing you the basic functions of plotting, but using use this link to sort of refer all of the different commands and options and different parameters you can use with each of these commands for your visualization. And so the next bit we're using is plotting a histogram. And the first one was a line graph, and we're going to move on to plotting a histogram with the same category or employment rate. And you can also choose the number of bins. And as I mentioned, you can change up the color, you can change up the size of the map, etc., using all of the different parameters that are available to use for this specific function. And then we are using another example, just a figure size, just changing up the figure size to change, sorry, the first one, to change the size of our map and the number of pins. And then moving on to the next one, what we're doing is using employment rate and plotting it against inner versus outer London. But here, as you can see, it's sort of, everything's merged. You can't differentiate between the two categories. So what we're doing is here, in the next step, we are providing a color palette. And all of my cells have been executed because I restarted my kernel and I had to execute the cells previously in the notebook. So you will already see the maps come up. So this bit is to differentiate the two categories, your inner versus outer London, and you can provide different colors. And let me bring it up. Let me bring this up. So yeah, so here, as you can see, all of this is overlapped. So you can change this by using this command right here, which is your alpha, and you can change this to increase or decrease the transparency or provide a more translucent effect to your plotting. And you can also use a legend to differentiate, to sort of identify each of these categories within your map as well. So yeah, pretty straightforward parameters which you would use while visualizing a data. Everything's available to use within Mapplotlib. And yeah, again, just some other variations of the visualization package itself. Of course, this is not a very good looking map, but it's just to show you all of the different things you can do while with plotting. You can have dotted lines, edges, and change the color of the bins, etc. Change the line widths as well. So you can do all of that using all of these different parameters that are available to use for this, for the histogram. And right, so this was just a basic example of using Matplotlib. We've used a line plot and histograms. Yeah, you can refer to the visualization link to sort of take you through all of the different categories of plots that you can use with Matplotlib. But we can move on to working with Cbond, which, as I mentioned previously, has a bit of a more yeah, the API with Cbond Cbond is based on Matplotlib, and it has a more diverse API which you can use to create advanced maps within using Cbond. So again, there's a link here to the documentation for Cbond as well. And this is again going to give you a lot of information about all of the different maps and everything that's available to use within the package. And for now, let's look at some of the maps within Cbond. You have your distribution plot. So again, the line plot is a default within Cbond as well. And this is sort of a distribution plot that we're using for our population density. And at a first glance, you can already see that the maps are a little more advanced and already have their own color scheme, and the legends are also automatically populated within Cbond. You wouldn't have to identify or mention them specifically like we did in Matplotlib. So there's a whole lot of it has a lot of advanced features which you can use when you use Cbond. And yeah, and then you have a bunch of category plots that you can use, and you can change the categorical plots by using the kind parameter within your code. And here what we're doing is using the category plot, and yeah, it's called cat plot, and we're using the turnout at local elections versus the political control on our y-axis to map this. Pretty straightforward, and this brings out, as you can see, you have labels that are assigned automatically with using Cbond. And we're changing up the kind here. So we're using a swarm plot, which is again a type of category plot. Again, these are very typical examples of how we can use it with our existing data set, but each of these plots have their own use for the kind of data you have. So yeah, have a look at the different category plots, and you can use the different plots which are most suitable for your data. And this is a swarm plot, and we're using median house prices and plotting them against the different areas. And yeah, and another example again is the employment rate. It's another category plot again, and the kind is a box plot. And this is the employment rate versus the largest migrant population. So yeah, you have your box plot and violin plots, which are which work better when you have more dense data within your data sets. So this way, as you can see, sometimes if it works much better when you have a lot of dense data for specific categories within your data set. So for that, box plot or violin plots, which is the next example, is more useful. So this way you can use all of these different category plots to visualize your different kinds of data. And that is the last bit of my visualizations. And yeah, I think I'm almost right on time. So yeah, to to finish off, we do have a few more exercises for to work with visualizations as well. So we've basically just given some exercises using everything that we've worked through within the notebook, and have some questions here which you can walk through and create your own visualizations. So for example, you have creative histograms that compare the gross annual pay for male and female employees using histogram. So yeah, do try these out yourself and see if you can work with what we've learned throughout the notebook, and answer each of these exercise questions. And if you do need to know the answer, just delete the hash here and execute this again, and this will bring up the answer to the exercise questions. But yeah, again, do try these out for yourself. If you do get stuck, you always have the answers right here. So just delete this, execute it, and execute it again, and that's going to bring up the answers to the exercise questions as well for visualization. And yeah, I've also put in a link here, which, as I mentioned, which I've also posted on in the Twitch chat, which I did earlier, which is a 10-minute introduction. Oops, sorry, that's not it. It's the link I've pasted. This one. Yeah, so this will give you a quick introduction. Before starting this notebook, you can always have a look at this link as well, which is a quick, like sort of a 10-minute tutorial to help you understand all of the different things that you can do with Pandas. And yeah, so it has some useful links as well. And so I've sort of put that here, which you can go through before actually going through this notebook as well. And there are some other optional exercises and further learning here. As you can see, you have examples for Pandas plots, Cbond, and some other tutorials and books, which we've also linked through, which you can refer for some additional information on Pandas. And yeah, I think we've come to the end of our Jupyter notebook. Hopefully, this was useful, and I'm going to leave my details here. So if you do have any questions from what we've covered today, you can reach out to me using any of these avenues. And yeah, hopefully you had please use the Pandas references that we've used in this notebook, and use your own data set, and work through all of these commands using your own data set, and create your own visualizations as well. And there's a lot of reference links and other examples and exercises that we've linked through, which you can also use for further learning. Thank you.